All right, so before I jump into the lesson, anybody have any questions, any homework questions y'all want to do? I will literally do your question right now. You can submit it instantly. Mhm. What's up? Tell me the question.
I don't understand. The
Can't really see it, but
first problem, number one,
what are they asking you for? Read it to me. Mhm.
reinforce the vocabulary before plastic arithmetic or operations, so of use or constant here. I don't understand that.
Let me see. Bring it
Yeah,
up.
thank you.
Unless it's something we didn't talk about yet. That could be why.
But it's
Yeah.
nothing here, not from yesterday, from
Oh, I
not
got it.
from yesterday, because I did in your assignment.
I got you.
I just
So look,
did it.
you have these words right here, right? And each one of them means something. Addition, subtraction, multiplication, division, right? So you're just matching the word with what it means up here. You're matching them together. So you're literally just putting like A, B, C, or D here, A, B, C, or D. Just
So I'm
that's it.
not using
No, no, no. Just these letters. You're just typing here.
this.
Yeah.
This
You're
is
welcome. You're welcome.
no.
I got you. Yeah. Anybody else? We good? All right. I hope that means that the homework is easy. Mhm. You know what though? Before I forget, because I surely did forget yesterday. Mhm. This piece of paper here. Make sure this is one and not three. All right. So before y'all leave, here's an attendance sheet. Just put y'all name on it. All right. And then we'd be good to go. So since we don't got no questions, I'm just gonna finish this lesson real quick. Real quick. Over the past 2 days, we've gone through some operations, addition, subtraction, multiplication, division. So today we're gonna put them all together. All right. All right. Give y'all 2 minutes to do this real quick. Today's 29. Mhm. We didn't get no marker on that. Mhm. So how we doing? We good? Give y'all a few more seconds. All right. Just kind of building off of where we left off yesterday. It was yesterday, right? Yeah, yesterday. All right, anybody got an answer? What you got?
-4.
Hmm? What you got? Five what? 510? Like this?
These saying too.
Huh?
I got these saying -510.
Okay, okay. Well, let's take a look. Let's take a look. All right. So if I rewrite this as a fraction, right? This would become 15.3 over the negative 0.03, right? Remember that whatever's in your denominator, that's going to go on the outside of your division sign. And in the numerator, that goes on the inside. All right. Now I have a problem, right? I don't do decimals in division. I use whole numbers, right? So you have to convert this into a whole number, right? The best way to do this, look at both numbers that you have here, right? Which one has the most amount of numbers, right, or significant figures after the decimal point, right? It's the divisor, this one right here, right? So to make this into a whole number, I could move this decimal point over two spaces, right? One, two. But here's the thing though, right? You got to be fair. What you do to one, you got to do to the other, right? So I got to move this decimal point over two spaces as well, just like that, right? So what does this become? This becomes -3 divided into 1,530, right? Then after that, just go ahead, do your long division, right? -3 goes into 15 how many times? Right? So -5 times, right? Right? And then -3 times -5 is
-5,
what is it? No, -3 times -5 is +15, right? And then we want to subtract that. That's 0. Bring down your 3. Now, -3 goes into +3 how many times? All right, 3 into 3. What is that?
6.
No,
Oh,
3 divided by 3.
1.
1, right? There you go. And then 1 times the -3, or -1 times the -3 will give me a +3. Subtract that, that's 0. Bring down your 0. -3 into 0 is 0. 0 times this. And that's how you show your work for this, right? So my final answer, right, would be -510. So good job. All right. Questions on this process of long division? Anybody? Not going to ask y'all to do this in the class, but I want y'all to know how to do it for future classes that y'all might take. Not statistics, something else. All right. All right, let's finish out this topic real quick, real quick. We only got two sections to do. We're gonna knock them out real quick, and then that's it. All right. So right here we on section 2.5, right? This is operations with sign numbers, exponents, and square roots. So we haven't spoken about that yet. So whole number exponents indicate repeated multiplication in the same way that whole number multiplication represents repeated addition, right? The base, right, the inside number of an exponential expression is the quantity immediately to the left of the exponent. So for example, the base of -4 to the 10th power is -4, right? Whatever is on the inside of the parentheses. The parentheses immediately, right, to the left of the exponent tells us that the number inside of the parentheses is the base, right? Now, the base of -2 to the 5th power is 2. Unlike the previous example, the quantity immediately to the left of the exponent is 2. So since we will only be concerned for now with whole number exponents, the rules for exponentials with negative base follow immediately from the rules for multiplying sign numbers. In particular, you should notice the following fact. The sign of exponentials with a negative base. So a negative base raised to an even exponent is positive, and a negative base raised to an odd exponent is negative. This is really important. Remember that. All right. All right. Remember that. Are we going to talk about why right now? Hey, how are you? Yeah. All right. So we will also from time to time encounter square roots written with the symbol like that. It's looks more like this. Hold on. Why is this not? 1 second. Okay. Looks more like that, right? The square root symbol. All right. Remember that the square root of a number is the non-negative number, which when raised to the second power squared gives the original number. So for example, the square root of 16 is 4, since 4 squared is equal to 16, right? For now, we won't go into the different issues that arise from the operation of taking square roots. In fact, for now, we will only consider square roots of perfect squares. So whole numbers, which are the second power of another whole number. So the first few square roots are 1, 4, 9, 16, 25, etc. If you haven't worked with perfect squares for a while, you should take a moment to make a list of the first 12 to 15 of them by squaring the numbers from 1 to 15, for example. So 1 squared 1, 2 squared 4, 3 squared 9, etc. Right? Hey, how are you? Welcome in. All right. There is one important fact that we cannot ignore when we are talking about negative numbers and square roots in the same section. We have already seen that any number, positive or negative, when squared, will result in a positive number. After all, squaring a number is raising the number to an even exponent of 2. For that reason, no real number can be the square root of a negative number, right? It's illegal to take the square root of a negative number. That forms something called an imaginary number. We're not getting into that in this class, right? But just let y'all know, right? So said differently, the square root of a negative number cannot be a real number. Warning, negative square root of 9 does not mean the same thing as the square root of -9, right? Negative square root of 9 means the opposite of the square root of 9, right? Which is +3. Well, excuse me, -3, right? But the square root of -9 is the square root of a -9, which is not a real number, as we just saw. So be careful of that. When the negative is under the square root, something's wrong. Excuse me, right? Excuse me. Hello. All right. So let's put everything together. This is called the order of operations. All right. In the previous chapters, we reviewed the basic arithmetic operations in the context of fractions and signed numbers. In a typical problem that we are going to encounter, however, there will be more than just one operation to perform. For that reason, the order in which we perform the operations is important. Usually, if we do operations in a different order, we will obtain different answers. So, for example, consider the expression with two operations, both division. 8 divided by 4 divided by 2, right? If we perform the first division first, we obtain 2 divided by 2, which is equal to 1. If we perform the second division first, right, we obtain 8 divided by 2 is equal to 4. The answers are different, right? But which answer is correct? So the order of operation is largely a matter of convention that has developed in history, and in fact, more of a question of topography, right, than mathematics, right? That, let's elaborate. I'm gonna give y'all the order right now. Yeah, I should probably write this down or something. It's gonna be something juicy right here. Something juicy. All right. So that being said, it is for the most part agreed upon as standard. So we describe the order of operations here as a rule. So here goes the order of operations. When an expression involves more than one operation, the operations are performed according to the following order. Operations inside grouping symbols. This is parentheses, this is brackets, even when you guys see like a fraction and it got that bar, right? Low key, that's a grouping symbol. You do the numerator by itself, you do the denominator by itself. All right. So operations inside grouping symbols from inside to outside. Parentheses are the most common grouping symbols, but there are many others. After you do the parentheses, the next one is exponents and roots, right? So when more than one exponent or root occurs in the same expression, it is standard to evaluate them from left to right, right? The same way that you read a book from left to right, all right? After you finish with the exponents and the roots, the next thing to do is your multiplication and division, right? So when there are more than one multiplication or division in the same expression, they must be performed in the order from left to right, the same way that you read a book, from left to right. All right. After you finish all the multiplication and division, then you do the addition and subtraction, right? So when there are more than one addition or subtractions in the same way, they must be performed in order from left to right, the same way that you read a book from left to right. All right. And this right here, this is the order of operations. Questions on it, anybody? We good?
Can you give us an example for the last operation? So if we go scroll
Mhm. You mean the first one, the
up.
8
Yeah,
divided by 4
8
divided by
divided
2?
4, yeah, they like equal to.
All right.
Next number one and then please.
This one?
Yeah,
All right.
um,
I'll just write it right here.
no.
Uh-huh. Oh, you mean
Yeah.
the top?
Uh,
Yeah.
Okay, I got it.
Yeah. You're welcome. All right, so look, 8 divided by 4 divided by 2. Do I have any parentheses or any grouping symbols here? Do I have any grouping symbols in this question? No, right? Any exponents or roots? Nah. Multiplication, division, right? Yeah, I have two divisions right here, right?
Yeah.
So how am I going to do it? I'm going to do it from left to right, the same way that I read a book, right? So just go straight across, right? 8 divided by 4 is,
Divided by 4.
yeah, 2, right? So then this is going to become 2 divided by 2. And 2 divided by 2 is, all right, so that's the right answer. And that's it. Yeah. All right, that's all the good stuff. All right. Let me make some comments real quick. So, referring to the example at the beginning of the section, the expression 8 divided by 4 divided by 2 involves two division operations. Since both are at the same level in the order of operations, the division should be performed from left to right. 8 divided by 4 divided by 2 is equal to 2 divided by 2 is equal to 1. If we had wanted to write the expression where the first division was performed first, we would need to use grouping symbols in order to do that, right? So we would have to group the 4 divided by 2 if we wanted that to be done first, right? It is worth noting at this point that both the associative properties of addition and the multiplication, as well as the distributive property of multiplication over addition, are all properties that concern the order of operations. For example, the associative property of addition says that repeated addition actually does not need to be performed from left to right. It can be performed in any order at all. The same holds true for multiplication. It is not true for subtraction or division, however. Neither subtraction nor division is commutative or associative. Important note, the unfortunate slogan PEMDAS, right? Some people might know that one, right? PEMDAS, right? Please excuse my dear Aunt Sally, parentheses, exponents, multiplication, division, addition, subtraction. Sometimes taught to help memorize order of operations might imply that the first operation performed is parentheses. This shorthand terminology is misleading. First and foremost, because parentheses do not represent an operation, right? It's the grouping symbols, right? That goes first. In particular, we draw attention to the fact that often cases confusions. Hold on 1 second. Let me just get this for y'all. Then we're going to just jump into an example and then call it. This fact always causes confusions that parentheses never mean multiplication. All right. So parentheses are grouping symbols indicating that what is inside the parentheses should be considered as a single expression. However, when no operation symbols is indicated between two expressions, the assumed operation will be multiplication. All right. So the expression 2, open parentheses, 3, close parentheses, involves multiplication. That literally means 2 times 3, right? For the same reason that we will see that 2x involves multiplication, that's 2 times x, right? In both cases, the multiplication is indicated by the fact that there is no symbol between the two factors of 2 and 3 in the first case and 2 and x in the second. Of course, 23 is simply the number 23. So the parentheses in the expression 2 open parentheses 3 close parentheses serves to separate the 3 as its own group from the 2. Keep in mind that parentheses are not the only grouping symbol. In addition to various shaped parentheses like brackets and braces, some commonly encountered grouping symbols include the bar used to write the fraction, right? So that's what I was saying. If we have a fraction, the top part is its own group, the bottom part is its own group. All right. where the numerator and denominator are both considered as two separate groups, and the bar over the expression in a radical symbol, like the square root, where everything inside the radical or under the radical sign, right, under the bar, is considered as one group. The following examples illustrate the order of operations, especially involving grouping symbols. Somebody tell me how to do this. I have 3 minus 2, open parentheses, -4 plus 10. How do I do this? Okay. Okay. So what is it? Good. -4 plus 10 we have is 6. Very good. So now I have 3 minus 2 times 6. What do I do next? What do you think? By 2 and 6, right? So now I have 3 minus 2 times 6. What's that? 12. Very good. All right, this is the hard part now, right? What's 3 minus 12? Hmm? -9. And that's it. That's how we do this. Any questions about this? Anybody? We good? All right.
What,
Mm-hmm. Go ahead, ask. Go ahead.
why was it, why was it -9 instead of -15?
Hold on. You know what? I just realized something. That's my eyesight right there. I didn't see that that was an 11. Let's try this problem again. My fault. But it's good practice for us, right? So this is 3 minus 2 times -4 plus 11. Sorry about that. That's my mistake. So what do I do first? All right, so what's -4 plus 11? 7, right? So this is 3 minus 2 times 7. What do I do after that? All right. So what do I get? 14, right? So this is 3 minus 14. And 3 minus 14 is? What is it? 3 minus 14.
-12, -11.
-11. All right. That's my fault. I didn't copy the question right. But good practice. We got 2 questions out of it. All right. Any questions about this? Okay. That was my fault. I copied it wrong. That was my thing. Let me hit y'all with. I got 2 more examples, and then we could call it just two short questions. Then y'all could meet your tutor and go over some review questions. All right. I'm gonna blow this one up because y'all know I wear glasses. All right, there y'all go. It's a little bit easier than the previous one. All right. So I have -2. You know what? Let me rewrite it. I have -2 minus -6 divided by 1 minus 5. Tell me what to do. Okay. And what do you get? Try again. +4. All right. So remember, right? Anytime I have a minus sign, whatever comes after that, I want the opposite of it. So the opposite of this would be -2 plus 6, right? Over the 1 minus 5. My fault, I didn't need this part here. right? So now -2 plus 6, that's because of the minus, this part, right?
-4.
-4, nope, try again. Try again. -2 plus 6, what's that?
+84.
Positive
No.
4. Very good.
Oh, yeah. Oh,
Mhm. Because it's like you have $6 and you pay 2 out, how much you have left? Right? You got 4. But what's 1 minus 5?
-4.
-4. And then 4 divided by -4 is
So,
no.
oh,
4 divided by -4,
-1.
-1. And that's it. All right. Any questions on this? There are homework questions like this, though. Got you. What- Keep, change, change. Think of it like that. Keep, change, change, right? So keep the first term, change the subtraction to addition, and then change the other term. Only when you have subtraction. Keep, change, change. Only subtraction. Only subtraction. Yeah. When you have the division of fractions, it's keep, change, flip, right? So division, keep, change, flip. Subtraction, keep, change, change.
And that's what we subtract.
Yeah. Mhm. So that's another little shortcut. It's an oldie but a goodie. All right, last example. This is the easiest one of all. Y'all know I like to do the easy stuff in class, right? Makes me look smart. So go ahead, how we do this? Okay. Tell me what to write. Which is, oh man, this becomes square root 25 minus 4 times 1 times -6. What do I do after this? You can answer. Yeah. All right. So what am I multiplying? All right, we can do that. -6 times 1 is. I mean, I like to do left to right, but it's legal what you were asking though, or what you said. Yeah. All right. All right. And -4 times 1 is, yeah, which is 4, right? So this becomes, that's in subtraction, but I'm not doing the subtraction yet because I got multiplication first, right? So 25 minus, they said 4 times 1, that's going to give me 4 times a -6. All right, what's next? All right, so what's 4 times -6? -24. That's what I'm talking about. So now I got square root 25 minus -24. What I want to do after that? All right. No. No. Hmm. Should add them. Anytime you have subtraction, period. Yeah. So keep, change, change, right? So this is going to become 25 plus what? Positive 24. And what's 25 plus 24? 49. All right. So this is square root 49. And what's the square root of 49?
No, no.
7.
Yeah.
All right, and that's it. All right. Not bad, right? All right, so that's all y'all homework. So y'all should be good now. Do y'all homework. Mhm.
And what's what is so the subtraction is keep, change,
Right.
and multiplication, what is it?
Keep, change, flip.
Keep, change.
Yeah, so you keep the first fraction, you change the division to multiplication in the middle, and you flip the last fraction. That's for division. Yeah.
Change. And
Mm-hmm.
that's for multiplication.
Mm-hmm. All right, that's all I got for y'all today. All right. It's 5, but that don't mean class is over. Y'all gonna meet y'all tutor. So come up. Mhm. Come introduce yourself. Can I take this down?
No.
No? Okay, good. All right. Yeah, whenever I'm asking this is because I have to download the file, before I push it to YouTube and all that, and that takes time. Yes. Yeah.
Okay.
You good?
Sir, yeah,
Yeah.
I was gonna,
Yeah.
I feel like take a 10-minute break first.
Sure.
Do it first.
Sure.
Or introduce myself first. So yeah.
Introduce and then if you want to
And
give
then
them a break, that's fine.
Okay. Hi, guys. Good afternoon.
Yeah.
My presentation is going to start after a little break so that you can kind of refresh yourselves, maybe use the bathroom. But my name is Javine. I'm a student here at BCC, and I'm going to tell you more about myself when we start. Is that okay? All right. So after you finish copying it, you can take a little 10-minute break. I'm going to log in the meantime.
All right.
Thanks, sir.
You're welcome. All right, let me just